So, today we are going to discuss solution, and we are going to discuss homogeneous solution. Homogeneous solution. The homogeneous solution is where composition of component present in the solution is uniform throughout the solution. Okay. So, let us first define what is solution. So, there is solute present and there is solvent present. The component which is present in large quantity, present in excess, present in large quantity is called solvent, and other components are called solute. So, there could be more than one other components in a smaller quantity, they will be called solute. In a binary solution, we have a solvent and a solute. Okay. So, to specify a solution, we need to talk about composition, and today's lecture is going to be about how to specify composition of a given solution. There are many ways to specify composition, and we are going to discuss them one by one. First of them is mass percentage. So, as the name suggests, it is the mass of the component in the solution divided by total mass of the solution, and we have to multiply it by 100 to convert into percentage. Okay, let us take an example. 10% glucose in water. That would mean 10 gram of glucose plus 90 gram of water to give me 100 gram of 10% aqueous glucose solution. So, I think this is straightforward. Another way to specify the composition is volume percentage. So, I just have to replace mass with volume. Volume percentage. So, volume of the component in the solution and total volume of the solution. So, this is the definition of volume percentage. Let us take an example. So, 10% ethanol solution in water. It means 10 ml of ethanol, the alcohol, plus enough water so that we prepare total of 100 ml of solution. So, the key word over here is enough water. If I mix 10 ml of ethanol with 90 ml of water, it is not necessarily going to give me 100 ml of solution. It could be slightly different from 100 ml. So, I have to add enough water so that the total volume becomes 100 ml. So, that would be 10% ethanol solution in water. Okay. So, the next unit to be discussed is mass by volume. So, we have already discussed mass by mass, that is mass percentage, volume by volume, that is volume percentage, and next one is mass by volume. Mass by volume. So, that is mass of the component in the solution in 100 milliliter of solution. So, this would be mass of the component in the solution and total volume of the solution, that would be mass by volume, and okay, this would be mass by volume. In case some component is present in trace quantity, it is present in a very minute amount, then we need a there is a convenient unit to express the composition is ppm. The full form of ppm would be part per million. So, the definition of this unit is part of the component, parts of the component divided by total parts. To convert into per million, I have to multiply by 10 power 6. So, for an example, that in the sea water oxygen is usually dissolved, it means it is there to support the marine life, and we know usually 6 into 10 power minus 3 gram of oxygen is present in 1 liter of sea water. So, the density of sea water is 1030 gram per liter. So, weight of 1 liter water is 1030 gram. So, if I want to calculate part per million, I have to parts of the component. So, that would be how many parts in this case kg. So, that would be part of the component of oxygen, that is 6 into 10 minus 3 divided by total parts. So, that is 1030 gram into 10 power 6. So, if we do the calculation, we will get answer as 5.8 ppm. It means 5.8 gram of O2 in 10 power 6 gram of water, sea water, or 5.8 microgram of O2 in 1 gram of water. This ppm, these parts can be expressed as volume. So, that would be volume by volume, how much, what volume of this component is present in a 10 power 6 liter of total volume. So, that would be volume by volume. We can have mass by volume and we can have mass by mass. We have calculated concentration of oxygen in sea water in ppm in mass by mass concentration unit. Okay. Next, very important unit with respect to this particular chapter is mole fraction. So, we are next going to discuss mole fraction, and usual symbol used for mole fraction is x. So, for component A, mole fraction of component A in the solution will be defined as moles of A plus total numbers of moles. If this is a binary solution, then there is a two component A and B present, then X A would be simply Na plus Nb. And similarly, I can write the mole fraction of component B. So, that would be moles of B divided by Na plus Nb, that is total number of moles, and it will be trivial to prove that Xa plus Xb equal to 1. So, this is for binary solution. If there is a more than two components are present in the solution, then mole fraction of ith component would be given by moles of ith component divided by total number of moles of each and every component. And again it will be not difficult to prove that summation over all the mole fraction would be equal to 1. Okay. Next we are going to discuss very important unit called molarity. Okay. And this unit is defined as moles of solute in solution divided by volume of solution in liter. Okay. Let us take an example, 0.25 molar NaCl aqueous solution, the solution which is prepared in water, it is an aqueous solution, would mean that we have dissolved 0.25 moles of NaCl in 1 liter solution. This is very important, 1 liter solution, not 1 liter of solvent. If I dissolve 0.25 moles of NaCl in 1 liter water, it is not necessary it is going to give me 0.25 moles molar NaCl solution, because by adding 0.25 moles of NaCl in 1 liter water, it is going to change the volume of this solution. It may be very minute change. For all the practical purpose, I can still consider the 0.25 moles in 1 liter H2O as 0.25 molar solution, but strictly speaking, it is not a 0.25 molar solution. If it is a concentrated solution, then we have to make sure that we are adding 0.25 moles of NaCl, I am sorry, it is concentrated, then we are adding number of moles in 1 liter solution. So, basically we are going to add enough water to the solution, so that the total volume becomes 1 liter. So, over here I am going to take 0.25 moles in a graduated flask, and I am going to add enough water that the total volume becomes 1 liter. It is not 0.25 moles in 1 liter water. Okay. So, next unit which we are going to discuss is molality. This is going to be very important when we discuss colligative property. Okay. The definition of molality is moles of solute in weight of solvent, and that is in kg. So, over here it is a volume of solution, and over here it is a weight of solvent. So, for example, 1 molar KBr solution in water, aqueous solution. So, KBr solution which is prepared in water would mean 1 mole of KBr in 1 kg of water. So, it is 1 mole of KBr in 1 kg of solvent. The weight of the solution is of course going to be 1 kg plus the molecular weight of KBr, because we are adding 1 mole of KBr. So, again to emphasize, this is the weight of solvent, and over here it is the volume of solution, not the volume of solvent. Okay, to understand better, let us attempt some exercise. So, we are going to attempt the in-text exercise given in NCERT book. Okay, so let me read it out. Calculate the mass percentage of benzene C6H6 and carbon tetrachloride CCl4 if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. So, the question is asking us to calculate mass percentage. Of benzene C6H6 and carbon tetrachloride if 22 gram of benzene. So, weight of benzene, let us say it is a component 1. So, weight of benzene is 22 gram and is dissolved in 122 gram of carbon tetrachloride. So, second component is carbon tetrachloride and 122 gram of this is used to prepare the solution, and we are asked to calculate mass percentage. Okay, let us go back to the definition of mass percentage. Mass percentage of a given component would be mass of the component divided by total mass, and to convert it to percentage, just multiply by 100. Okay. So, this is a straightforward problem. So, mass percentage of C6H6 would be simply given by mass of benzene, that is 22 gram divided by total mass, that would be 122 plus 22 multiply by 100. So, this would be equal to 22 divided by 144. So, 15.3%. And the mass percent of CCl4 can be simply calculated using either this formula or simply 100 minus 15.3, that would be 84.7%. One can check if I just calculate using the formula given, that is mass of the component, that is 122 divided by total mass 144 into 100, I am quite sure you will get the same value. Okay. So, this is completes the problem, but let us go one step further, and with the given data let us try to calculate mole fraction. Okay. So, what is the definition of mole fraction? Mole fraction is defined as mole fraction of component 1 is equal to moles of component 1 divided by total moles, that would be N1 plus N2. Okay. So, we are given mass. So, from mass we need to convert it to the moles and we should get the answers. Okay. Let us see. So, the component 1 is C6H6. So, the molecular weight would be 72 plus 6, that would be 78. So, if I divide this thing by 78, I should get N1 moles of component 1. The second component is CCl4. So, molecular weight would be approximately 12 and atomic weight of chlorine is approximately 35.5 multiplied by 4. So, 71, 142. So, that this would be 154. So, if I simply divide this thing by 154, that will give me moles of component 2. And if I just plug in this information, I should get the answer. Okay, let me simplify this first. So, 22 divided by 78, I get 0.28, 0.28, and 122 divided by 154, 0.79 moles. This unit is in moles. Okay. Now, we have all the information required to complete this problem. So, mole fraction of benzene component 1 would be simply 0.28 divided by 0.28 plus 0.79. 0.26, 0.26. And of course, I can use the similar formula for calculating mole fraction of component 2, or I will simply can calculate it by just using this information 1 minus x 1, and that would be 74.74. Okay. So, this completes this problem. Okay, let us try another problem from the in-text question, that is 2.3. Calculate the molarity of each of the following solution. A, 30 gram of cobalt nitrate hydrated in 4.3 liter of solution. B, 30 ml of 0.5 molar H2SO4 solution diluted to 500 milliliter. Okay. So, the question is asking us to calculate molarity. So, the solution A is 30 gram of this compound cobalt nitrate dot 6 H2O in 4.3 liter of solution. So, volume of solution is given as 4.3 liter. This is the volume of solution. So, we are asked to calculate molarity. Again, going back to our ABCD basics. So, that would be the definition of molarity would be moles of solute divided by volume of solution in liter. Okay. So, volume of solution is given right here. So, that is not a problem. We need to calculate moles of solute. So, to calculate moles of solute, we need to divide this weight of solute by molecular weight of this solute. So, let us use the periodic table to find out the molecular weight of atomic weight of cobalt, that would be 58.93, that is atomic weight of cobalt nitrate. So, 14 plus 3 oxygen 48. So, 14 plus 48 62 multiplied by 2 124 and 18 multiplied by 6 108. Okay, and total if we add, it would be 290.93. So, moles of solute is simply going to be 30 divided by 290.93. So, we have all the information. Now, I can plug in we have moles of solute, put it in there, volume of solution, just put it in there and we get the answer. So, the moles of solute N2 would be 30 divided by 290.93. So, 0.103. So, the molarity is simply going to be 0.103 divided by 4.3 in liter. So, the answer is going to be 0.024. 0.024 molar solution. Okay, let us discuss another problem. 30 milliliter of 0.5 molar H2SO4 is diluted to 500 milliliter. So, in this solution of 30 ml, we are adding enough water, so that the total volume becomes 500 milliliter. So, the amount of or moles of H2SO4 present in this solution or this solution remains same, because we are just adding water. So, there are two ways of doing it. One is, if we are diluting this solution from 30 to 500, then the molarity we can simply calculate by 0.5 into 30 divided by 500. That will give me the answer. Just to grasp the concept, let us do it differently. So, we can grasp this concept better. So, how much H2SO4 is present in this solution? Okay. We are given the molarity, that is 0.5 molar solution. We need to calculate moles of solute, divided by volume of solution in liter. So, in liter it would be 30 divided by 1000. Okay, moles of solute in this solution would be 0.5 multiplied by 30 divided by 1000. And these same number of moles of solute is being used to prepare this solution. So, the concentration of this solution is going to be moles of solute, which is given to us, divided by volume. So, the concentration would be simply 0.5 into 30 by 1000, that is moles of solute divided by volume of the final solution, that would be 500 by 1000. So, you see that we got the same answer, we got it earlier. Okay, let us do another problem from in text question. So, the question is, calculate the mass of urea required in making 2.5 kg of 0.25 molar aqueous solution. So, he is asking to calculate the weight required for a given molar solution. The molality is given. So, let us look at the definition of molality first. Molality is moles of solute divided by weight of solvent. So, in this problem, making 2.5 kg of urea solution. So, we are preparing 2.5 kg of solution, and the solution is going to be 0.25 molar. The symbol used for molarity is small m. So, 0.25 molar urea solution, and urea is NH2CONH2. This is the formula for urea, which will be needed later. So, if we want to use this definition of molarity, we have the moles of solute. Let us say we want to calculate moles of solute, which we can convert to later the weight of solute, weight of urea, just by multiplying the molecular weight of urea. And over here we need weight of solvent. we are given the weight of solution, not the weight of solvent. So, first we need to assume, let us say the weight of solute is W. This is weight of solute. Okay. Then the weight of, let us say this is in kg, weight of solute in kg. Then weight of solvent is going to be 2.5 minus W in kg. And moles of solute that we need, for that I need the molecular weight of urea, that is 14 to 16, 12 plus 16. So, 16, 48 plus 12, 60. Okay. So, moles of solute in terms of W is going to be W, which we assume in terms of kg. So, W into 1000 divided by 60. So, that is the moles of solute. Now, we can have all the information and we can put it in there. So, molality is 0.25 molar, moles of solute is W into 1000 by 60, and weight of solvent is 2.5 minus W. So, we have a one equation and one unknown, that is W. Simplifying this is a little bit, we get W divided by 2.5 minus W is equal to 0.25 into 60 by 1000. 0.25, so 1.5 into 10 power minus 2. Point 0.15. Okay. And let me put simply adding numerator and denominator will simplify the whole equation. That would be W 2.5 minus W plus W is equal to 0.015 1 plus 0.015, and answer is straightforward. W is equal to 0.015 divided by 1.015 into 2.5. Okay. So, at the beginning itself we could have neglected W with respect to 2.5. Okay. That means basically taking neglecting this 0.015 with respect to 1. That should have been acceptable solution, but anyway we can complete it without bothering about that. Otherwise, if we do the problem by making that approximation, we always have to check it later, as we will see it later on. So, the answer becomes 0.015 multiplied by 2.5 divided by 1.015 equal to 0.37 kg or 37 gram of urea is required to prepare 2.5 kg of 0.25 molar solution. Okay. All right. Okay, let's do the next problem. Okay. So, the next problem is the same in text question 2.5. Calculate A, molality. It is asking us to calculate molality. B, molarity. C, mole fraction. Of Ki if the density of 20% mass by mass aqueous Ki is 1.202 gram per milliliter. So, we have a Ki aqueous solution which is 20% mass by mass. Mass by mass, and the density of this solution is 1.202 gram per milliliter. Okay. So, 20% mass by mass. So, this is a mass percentage. The definition of mass percentage is mass of the solute divided by total mass. So, it is very clear that this solution contains 20 gram of Ki and 80 gram of solvent. Solvent, that is water, because aqueous solution. Okay. Now, we have to calculate those quantity one by one. So, molality, definition of molality. Molality, that will be moles of solute divided by weight of solvent. So, to calculate moles of solute, since we are given weight of solute, to calculate moles of solute, I just need the molecular weight of potassium iodide. Okay, let us use the periodic table again. Potassium is 39.1, iodine is 126.9. So, that gives me 166.0 gram per mole. So, moles of solute, so moles of Ki. Moles of Ki in the solution is 20 gram divided by molecular weight of Ki, that is 166.0 gram per mole. So, answer would be 20 divided by 166, that is 0.12 moles. So, the molality is now straightforward. So, that would be moles of solute, that is 0.12 divided by weight of solvent, that is 80 gram, and we need the weight of solvent in kg. So, we have to divide this whole thing by 1000. So, answer which come out to be 120 by 80. So, this is a 1.5 molar solution. Okay. What about molarity? Okay. So, I do not think I will need this information anymore. So, let me use this space. Okay. Molarity. The definition of molarity is moles of solute divided by volume of solution in liter. Okay. So, moles of solute we have already calculated 0.12. What about volume of solution? We know the total weight of the solution, that is 100 gram. We are given the density somewhere, that is 1.202 gram. So, the weight, so volume would be weight, that is 100 gram, and the density is given. So, if I divide by density, that is 1.202 gram per milliliter, that will give me volume. So, answer is 100 divided by 1.202. 83.19. 83.19 milliliter. So, now I have all the information required. So, this would be the molarity of this solution is going to be moles of solute, which is given right here 0.12, volume of the solution which is given here 83.19, and I use that information and I will have my final answer 0.12 divided by 83.19. But I need to convert that milliliter into liter. So, that I just do by dividing by 1000, and answer is right there. So, let us do this calculation. 120 divided by 83.19. 1.44. Okay. So, now the last quantity which we need to calculate is mole fraction. Okay. Let me now clean this part. So, mole fraction of Ki would be moles of Ki divided by total moles. So, this is a binary solution. So, that means moles of Ki plus moles of water. So, of course, we moles of Ki is already given, it is 0.12 moles of Ki plus moles of water. So, to calculate the moles of water, we already know the weight of water and we know the molecular weight of water. So, the moles of water is simply going to be 80 divided by 18. So, if one wishes, they can ignore 0.12 with respect to approximately 4.5. It will not be such a big error, but let us keep it, since we have a calculator. During the estimation, one need to ignore those quantities. So, first let's calculate that 0.12 divided by in bracket 0.12 plus 80 divided by 18 bracket close 0.026 0.026. So, you can see that nearly in terms of mole fraction 99% is just water. All right, let us do now some more problem from the end of the chapter. So, this is problem number 2.7 from NCERT textbook from the end of the chapter. Okay, let me read it out. A solution is obtained by mixing 300 gram of 25% solution and 400 gram of 14% solution by mass. It is a solution by mass. Calculate the mass percentage of the resulting solution. Okay. Okay. So, we are mixing two solution. The solution is obtained by mixing 300 gram of 25% and 400 gram of 40%. So, these two solutions are added together and the resultant solution we need to calculate for the resultant solution mass percentage. Mass percentage. So, in this first solution 25% of the solute is present and in this solution 40% of the solute is present. So, mass percentage is of this solute. So, mass of the component in the solution divided by total mass of the solution and for percentage multiply by 100. So, in the resultant solution the component this solute is going to come from these two individual solutions. So, how much solute is present in the very first one? It is a 25% of 300 gram, it is by mass. So, 25 into 300 divided by 100, that many gram of solute is present in solution 1, that is 75. Same way in the second solution the solute present is 400 into 40 by 100. So, that is 160 gram of solute present in the second solution. Okay. So, we know the mass of the solute, mass of this component, that would be simply add these two. Now, we need total mass, that is straightforward. We are adding 300 gram of solution 1, 400 gram of solution 2. So, total weight is obviously going to be 700 gram. So, now we have all the information and I can complete this problem. So, total solute present is going to be 235 divided by 700 into 100. So, the answer comes out to be approximately 21, 25, 24, approximately 33.6%. Okay. Okay, let us do one last problem for today, the next problem. Okay. 2.8. An antifreeze solution is prepared from 226 gram of ethylene glycol and 200 gram of water. Calculate the molarity of the solution. If the density of the solution is 1.072 gram, then what shall be the molarity of the solution? So, he is asking molarity and molarity. So, he is asking molality and molarity. Okay. And the solution contains 222.6 gram of ethylene glycol, gram of ethylene glycol in 200 gram of water. And the density of the resultant solution is 1.072 gram per milliliter, and the formula for glycol is C2H6O2. Okay. So, this is used as an antifreeze. Okay. Let us first try to calculate molality. Molality is defined as moles of solute divided by weight of solvent in kg. All right. So, first we need to calculate the moles of solute. We are given weight of solute. So, to convert this weight of solute to moles of solute, I need a molecular weight of the solute. So, that would be 24 plus 630 plus 32 62. So, the molecular weight is 62 gram per mole. So, the moles of solute would be simply 222.6 gram divided by 62 gram per mole. Okay, let me calculate this. 222.6 divided by 62. 3.59 mole. So, 3.59 moles of solute is present and the weight of solvent is given right there. So, this problem becomes straightforward. So, this is nothing but 3.59 divided by weight of solvent in kg. So, that would be 0.2 kg. So, this solution is 3.59 divided by 2. So, this would be around 18 or 17.95 molar. 17.95 molar, it is a highly concentrated solution. Okay. So, we have calculated molarity. Now, let us try to calculate molarity. The definition of molarity, let us go back to the basic definition. Moles of solute divided by volume of solution. So, moles of solute we already know is 3.59 mole. Now, we need to calculate volume of solution. For that, we need to use this information. We need to calculate what is the total weight. The total weight we are, since we are mixing this many ethyl glycol, these many gram of water. So, total weight is simply going to be, just add this up and that would be 422.6 gram and divide that by density 1.072 gram per milliliter, and that will give me volume of the solution. Okay, let us calculate that. So, answer comes out to be 394.2 milliliter. So, now we have all the information required to calculate molarity. So, moles of solute is right there 3.59, volume of solution is right here, but we need volume of solution in liter. So, this would be simply 0.394, and if we do this calculation, we will get the molarity, that is 3.59 3.394. So, 9.11 molar solution. Okay. That is where we will end today's class. Thank you.